Okay, we're beginning Unit 5, and in Unit 5 we're going to continue the study of lines. We're going to look at, first of all, parallel lines and their equations, and you can see where I've already filled these in your notes that lines with the same slope are parallel to each other. But what we're going to do is we're going to graph these four lines right here. These four. 1, 2, 3, 4. And you'll notice that they all have a coefficient of 2. So that's the slope. So they all have the same slope. So according to this, lines with the same slope are going to be parallel to each other. Well, of course, right here, we are going to graph this line, but we have to know where to begin because there is no number in the back. And we should know that when you don't have a number, the number that represents nothing is 0. So we're going to put a 0 on the end, and that's where we're going to begin. This line has a slope of 2, as do all the other ones. So you'll notice I created this trail of points. I went up 2 over 1, up 2 over 1, and I continued that trail of points to get a nice clean line, and now I'm going to connect. The next one, I'm going to begin at 4, okay? And I'm going to do the same thing. Rise 2, run 1, create a trail of points, and connect. And you can see those two lines are parallel. Now what parallel means is that they will never cross over each other. It's kind of like the lines down the middle of the road, the double lines. They're parallel. There's lots of parallel lines in our world today, but we'll talk about that later. Okay, the next one we're going to begin at -5. And we're going to create a line that has a slope of 2. And the last one is the -8. And again, there's your trail of points that have a slope, rise 2, run 1. And you can see that all these lines are parallel to each other. Okay, so moving on. So let me just begin by saying that the slope is where you're going to look to see if two lines are parallel. So in this set of instructions, it says find the slope of a line that's parallel to this line right here. Well, all we have to do is have a slope of 5 over 2, and we will have a line that's parallel to this given line. This line has a slope of, remember the slope is the coefficient of x, of -2. So any line with a slope of -2 will be parallel to this given line. This is the given line. This one we cannot tell the slope yet because it's not written in proper format. We have to move that 3 over to this side. Now I'm not really concerned about it, the 18, because that has nothing to do with slope. It's the coefficient of x. So stop there, and the slope of any line that is 4/3 will be parallel to this line right here. So moving down here, use your knowledge of parallel lines to answer these questions. Write the equation. Okay, so here's a blast from the past. Write the equation. That should bring up some memories. And those memories are, who are you going to call? Yep, that's the box. And so we have a line that has a slope of -4. We want to write another line that has a slope of -4 but goes through 0, -8. Okay, so this is a totally different line. So we know that the second box will be a -4. Y goes with Y, -8, and 0 goes with X. And then we just clean it up, move the 8, and we have our equation Y equals -4x minus 8. I'm just going to stop here a minute. I know I'm talking really fast, and you're probably stopping the video and copying the notes down. I would suggest that you just listen to the whole video and then go back and fill in the blanks. It's just not as broken up. Okay, so again, let's look at number 5, the same thing. The only difference is we don't know the slope of the given line because it's not in the right format. We have to have y equals. So we're going to divide by 3. And again, I'm not going to divide the negative 12 by 3 because I just want to grab the slope off of this line. Because I'm going to write another equation that has a slope of 2/3 so that it will be parallel to this line. Okay? So bring out your template and drop in your numbers. Now this says it crosses the y-axis at 6. So that goes through 0, 6. Okay, so there you go. And then just pull your 6 over to the right. Now what you may not have noticed in both of these equations is they gave you the y-intercept. So you could have bypassed this and just put in -8 and +6. But since this template, the box template, is used quite a bit, I decided to use it. All right. Now, here we go. This time it's not going through a y-intercept. It's going through 8, 1. So again, what is the slope of this line? And you should say the slope is 1/4. Now we're trying to write a totally different line that goes through this point. This line right here doesn't go through this point. We want the two lines to be parallel, so all we're going to use this line for is to grab the slope from it. Okay? So the slope is 1/4. And that's where we're going to put it. Then we're going to put the other 2 points, 8 and 1, and we're going to clean it up. 1/4 of x, 1/4 of 8, and then we're going to add 1 to both sides and finish it off. By the way, I'm sitting out my back patio, so hopefully all this noise, the birds and trees and cars, is not going to be too disruptive. Okay. Question number 7. A line parallel to this line right here passes through this point. This is the line that we're going to use just to grab the slope from. And the slope is 2.4. Okay, and we're going to put the 5, -5 with the y. It converts to a positive, and -10. Then we're going to distribute. Anytime you multiply by 10, something by 10, it just makes the number 1 decimal point bigger. Okay, it makes the number bigger by 10. And then we're going to subtract 5, and this will be the slope of the line parallel to this line. All right. Now let's talk about horizontal and vertical lines. Horizontal and vertical lines. Okay, I filled these in as well. We're going to sketch. Now, I sketched this. You're welcome to sketch this as well, but it doesn't say where to put it. I just put it at y equals 3. And they said to sketch a dotted line. That's parallel to the x-axis. Okay? And to use a solid line, and again, I just randomly, arbitrarily chose -2. I could have chosen a line down here or a line over here, but it had to be parallel to the y-axis. Okay, that was Dolly. And Dolly was barking, so I came inside. So hopefully no more disruptions, but who knows. All right, so a line that is parallel to the x-axis will begin with y. So look, x-axis begins with y, has a slope of 0, and is horizontal. A line parallel to the y-axis will be undefined. okay? And it'll be vertical. Now, the way I teach horizontal and vertical lines is when I walk across the floor, I am experiencing zero slope. There is no slope. I'm not experiencing any incline or decline, whichever. But there's no way for me to walk on a vertical line. It's impossible. So that's the one that's undefined. All right. Now, let's go down here. Determine the slope of the line that is parallel to the x-axis. So remember, if it's parallel to the x-axis, it's going to begin with y. Well, all you have to do is look at the y value. So the slope is 0, and the equation is y equals -8. Okay, let's back that up. We got ahead of ourselves. Natasha says the line x equals 7 is parallel to the x-axis. Those two will never be, they have to be opposites. So this should have been y equals 7. Okay, so I would disagree with that. And x equals 7 is not parallel to the x-axis. Y equals 7 is parallel to the x-axis. All right, and there's proof. Just draw you a picture. X equals 7 is not parallel to this line right here. All right, write the equation of the line that is parallel to this line and passes through the point 2, 3. There's two ways to do this. Write the equation. Who are you going to call? You are going to call your friend, the box. Okay, the slope of this line is calculated by finding two readable points that go through the crosshairs and counting up 3 and over 1. And then using the point 2, 3. So fill in these boxes and simplify. Or you could have plotted the point 2, 3, given it a slope of -3, and looked for the y-intercept. So you would have gotten the same thing doing it this way. The only problem with this method is there's no certainty that this will go through a readable point or a point that is on your graph. Like it might be off your patch of graph paper. All right. These two lines, you have two lines. One line contains these points. The other line contains these points. We want to determine if their slopes are parallel. And again, I just gave out the word, so we just need to calculate the slope. Well, slopes are found by subtracting y's and subtracting x's and coming up with a fraction. So that's line P. Line M goes through these 2 points. So I'm going to subtract the y's and subtract the x's and then compare the slopes. They are the same, so that means that the lines are parallel. Don't you like my fancy little S? Yes, I think it's pretty cool. All right, we're almost there. Nope, we are there. We're not going to do the ACT question. All right, ladies and gentlemen, make sure you get all these notes, and now what I want you to do is go to Delta Math, and I want you to practice. There's 10 questions up there. I want you to practice those questions over this material. And when or if you finish, you can start working on your skills check practice number 3. It is due the next time we meet, and you will be given a skills check over that material. All right. Y'all have a great day.